So howdy, my name's Mark Williams. I'm a professor here at CU Boulder, and welcome to the jungle. We're going to talk about probably the most controversial subject in the United States today, and that's fracking. So what is hydraulic fracking? And so let's start with a level playing field. So what hydraulic fracking is you're putting in this water and sand solution under high pressure to break up the bedrock, the rock formation that is containing oil or natural gas. And these rock formations, shale and things like that, have really tiny pores, so you can't get the oil and gas out, and we need to make bigger pores. So by putting in that fracking fluid, this mixture of different soluble products, we can exert pressure and actually break the bedrock. And that's the fracking process. It's really taken off since 2004 because industry has perfected horizontal drilling. So now they can drill down to the rock formation, that might be 5,000 feet, and then turn the drill sideways in that rock formation that might be only 100 feet thick and drill for a mile. So when they do unconventional oil and gas extraction and they frack, they're putting in this fluid that may be dangerous. Some people think it's dangerous. What industry will tell you is that fracking fluid is 90% water, 9.9% sand, and that's absolutely right. And then the other chemicals that they put in are pretty similar to what you would find underneath your kitchen sink. And so no problems, all right? And then Coburn put out a paper last year, 330 carcinogenic chemicals are in fracking fluid. And she's right in the sense that all those chemicals have been used in fracking fluid, but they're not all used at the same time. So that doesn't really help you very much. And partly what gets people concerned is it can potentially contaminate groundwater, and we don't know what groundwater is. The public doesn't know. It's this mysterious fluid beneath the ground. All right, one of the first papers to actually look at the potential groundwater contamination from fracking was a paper by Osborne et al. That came out in 2011 looking at contamination of domestic wells potentially by fracking. And this was in Pennsylvania, Marcellus Shale, and what's infamously called the Duke study showed that methane concentrations were up to 60 milligrams per liter, and the closer you were to a fracking job or a fracking well, the higher the concentrations were in general. And in fact, there's this magical distance, which is about 1 kilometer. If your domestic well is more than 1 kilometer from a fracked well, they almost never saw methane in there. There are no health effects from methane, so it's not a concern, except that when the concentrations get above 10 milligrams per liter, you can light it on fire. And you could blow up things with it. And so 60 milligrams per liter, you could actually, if you were in a room that wasn't vented, you could actually blow up your house or that room. So there's some concern there. And the question is that methane from fracking or is it natural? Because there's a lot of naturally produced methane from biological products. And there's a magic tool that tells us whether or not this is natural methane or from oil and gas extraction. And that's an isotope of the carbon in methane, C13. And what the Osborne study showed was that most of the isotopes in the methane that they collected were thermogenic or from oil and gas production. So what do we want to know about water? We want to know what the volume of water use is. We want to know what the quality of that water is. Are we actually contaminating our groundwater reservoirs, our aquifers? Can we treat that water so that nothing is contaminated? So let's chat about water quantity. Fracking does in fact use a lot of water. So here in Colorado, where we're at, sort of the average amount of water used to frack a well is 3 million to 5 million gallons of water. That's a lot, or at least it seems a lot. But what the oil and gas industry will tell you is that's 1/10 of 1% of the water use in Colorado. And are they lying? No, they're right. It's a very small amount of water relative to all the water use in the state. However, we have parts of Colorado, particularly northeastern Colorado, Weld County, that has very little water. And what's happening there is that the oil and gas companies are actually outpricing and outcompeting agriculture and municipal water supplies for that water. And in some cases, they're paying over 1,000 times what ag pays for the same amount of water. And I just want to point out a potential problem down the road, which is that with climate change, we may have less water, and so there's potential conflict or interaction between climate change, water availability, and fracking. All right, so let's move on to water quality. And so one of my colleagues here, Joe Ryan, is looking at, and we had that Coburn paper with 300 plus chemicals that can kill you. And so he asked the question, well, what chemicals should we really be concerned about? And it's not just that the chemical may have been used in fracking fluid, it's that it also has to be persistent. By that we mean it doesn't break down and convert to something that's not a problem. It's got to be mobile. That is, it has to be able to move. A lot of constituents don't move, and so you don't have to worry about them. And is there a path for that water with those chemicals to move through? What I have on the screen right now is a diagram that shows fracking. We have the well going down to rock formation. We're bringing that water up. And the question is there a pathway for that fracking fluid to get into an aquifer or a domestic well? One of the pathways that's hard to just know if it's there are abandoned wells. In the Marcellus Shale, where there's problems, we know that one of the pathways that methane is getting up into domestic wells is from abandoned wells. And the first oil well in the United States was 1851 in Pennsylvania. So there's just a lot of abandoned wells there. Another way that you can get movement of that water if there's fractures. So earthquakes occur where there's fractures. And so these fractures are pipes that water can move on, or in particular, gases can migrate through. So one of the things that we're doing is looking at methane in wells, just the way that Osborne et al. 2011 study did, and seeing if concentrations are higher, the closer you are to a fracked well. And the answer is yes. So we see pretty much the same pattern. There's a lot of zeros, but where there are high concentrations, that always occurs close to wells less than a kilometer away. All right, now is that methane, which goes up to 30 milligrams per liter above explosive levels, is it natural or is it from oil and gas? In Weld County, where we're doing evaluating this, there's 20,000 active wells today. That's a lot. And in fact, we couldn't find any domestic wells that were more than 2 kilometers away from a fracked well because the density is so high. And what we find is that, in fact, isotopic value of methane, that's like a fingerprint, shows that it's not thermogenic, it's not from oil and gas, but it's from biogenic processes, naturally occurring processes by microbes that produce methane. But what we find is that the closer you are to a fault, the higher the concentrations as well. So it looks here like that gas is migrating along faults, and there are a lot of faults in this area. What's the real potential problem from fracking in terms of water quality? It's not the fracking fluid, right? There's just not much in the way of problems there. When you frack, you're putting water in, and you have to take that water out to let the oil and gas out. As well, you're actually fracking an aquifer, right? So there's water in these rock formations, and you have to remove that. And that's 1 million to 2 million gallons of water from each fracked well. What are you going to do with it? Because that water is nasty. And it's nasty not because of the fracking process, but because of how that rock formation was formed. These are formed in near ocean environments, so it always has a lot of sea salt. Bring that to the surface, put it on your farmland, it's going to kill the plants. It's got organic carbons, which can be carcinogenic because that's what you're pulling out of this, right? Oil and gas are organic carbons, which includes benzene, which is a known carcinogen. So you need to dispose of it. Initially, they put it on surface ponds. Bad idea. That's where most of the problems are, is leakage from surface ponds. They just always leak. The idea is to let that water evaporate. So cool, except those volatile organic compounds are also evaporating, some of which are carcinogenic. So it's just not a good idea. That's almost never done in Colorado anymore. Still places in Utah where it's done. Uinta Valley, where there's been a lot of work. Ozone concentrations are through the roof because of that release of VOC, way above federal limits. Another way to dispose of produced water is actually to put it on dirt roads. And that's being done here in Colorado. And we put mag chloride and things like that to when it's snowing to keep the ice down. You can put produced water to do that because it's high in salts, and particularly on dirt roads to cut down on dust from those. And actually, I don't have a problem with that as long as it's low in VOCs and relatively low in salts, but they don't test, so they don't know. And it's really easy to get a permit. Right, so we know there's bad things with this produced water. The way it's disposed of now in general is deep injection wells, all right? And that's out of sight, out of mind. So we put that produced water in the trucks from the formation, drive to an injection well, and then put that water down to 5,000 feet, 10,000 feet into an aquifer, because that rock formation has to be able to hold water, right? Because we're putting water in there. And one of the things that we're doing is sacrificing those aquifers. And right now they're not economically viable because they're so deep, it costs money to get that water up. But again, that interaction with climate change, I guarantee this will happen. In 50 years, we're gonna want the water in these aquifers that now is too expensive to pump. So we're sacrificing that. Within the last year now, we know that we can get earthquakes, seismicity caused by deep injection because you're putting water under pressure. We can't map the fault system underground very well. And it turns out some of these wells are close to or on faults, and you're lubricating those and increasing the pressure. Two bad things, and earthquakes go up. So Oklahoma, what are the values on that? No magnitude 3 earthquakes over the last 10 years, but starting 3 years ago, there's hundreds, somewhere around that line. I mean, it's just amazing the change, and that's definitely from that deep injection. Here in Colorado and Wyoming, we produce 2.4 billion barrels of produced water just in 2013 that we have to dispose of. All right, so is there a better solution than deep injection, than surface ponds, than putting it on roads? And there is. That's treating it. Treat and reuse, that is totally a win-win situation, because now we're not reducing water quantity. We have more available water. There's less truck traffic. Economically, it could be cheaper potentially for the oil and gas industry. We have a group that's actively researching ozone, UV, really nice work with membrane technology. All these things have been tested by our group. They work. The problem is scaling to an oil field. And each oil field is going to have a different recipe for their produced water. And so we have to change the treatment based on the water quality from that particular gas patch. We know how to do it. It's expensive. It's being done in some places. So if we could make it economically feasible, i.e. increase the cost, I think we could do that at pretty much all the wells. All right, so let me summarize what we know. There's just a small number of compounds of concern. In terms of all those hundreds of compounds that have been known to be in fracking fluid, Not that many are hazardous. Very few migrate. Um, there's just very little reason to be concerned about fracking fluid. And Joe Ryan's going to have a paper out on that pretty soon. What we also know is there's a very low incidence of groundwater contamination. Probably hundreds of thousands of wells. There's over 50,000 active wells just here in Colorado that have been fracked. Oil and gas industry likes to say there's never been a single problem. That's not true. But what is true is there have been actually very little problems. So the number of contaminated wells is in the tens, dozens, not thousands or anything like that. One of the reasons that industry was able to say that there was no contamination is because in some wells where we saw benzene or other things, high methane that might be because of fracking, they just go, it was always like that. So you need baseline information. And our group has put together a well user's guide to help instruct you so you can go out and collect your own samples and analyze for analytes that we recommend to get that baseline data. Where there may be more problems, particularly for human health effects, is air quality. And we're focused on water here, but we really need to look at air quality. Our group is doing that, but it's a much more difficult problem because concentrations change continuously. All right, so a couple of things that we don't know that we would like to know more about. There are compounds that we haven't identified yet that industry has not shared with us. We'd like to know what those are. One of the things that's happening is where fracking is taking place is at high pressure and high temperatures because you're deep underground, and that changes the chemistry of compounds. And nobody has any idea if that makes them less of a problem or more of a problem. And we need some research on that. And we really need a better idea of the flow paths. Because if there aren't any flow paths, you don't have to worry much about contamination. If there are flow paths, then we have to be more worried about contamination. All right, and then here's the last thing, is this huge increase in fracking started in about 2004. Fracking itself goes back 50 years, but it was the advent of horizontal drilling that really made it profitable, along with increasing oil prices in the mid-2000s. And so all this horizontal drilling and huge amount of fracking has only been going on for 5 or 6 years. How are the wells going to respond 20 years down the road, 30 years? Is water actually migrating now at very low velocities, but might reach an aquifer in 40 years or 50 years? At this point, we can't answer those questions. So students, it was great talking to you. Enjoyed it. And hope you like all the different units here in Water in the West. Bye.